This is Ritesh here, and in this video, I will explain you what is naive Bayes, and we will also derive the formula for naive Bayes algorithm using probability, and we will use Bayes theorem in that. And if you don't know Bayes theorem, then please watch my video. I will give the link of the video in my description. So let's start with the naive Bayes. So the name is naive Bayes. I will tell you why the name is Bayes, but for now you know that Bayes name is added because we are using Bayes theorem here. So what is Bayes theorem? Bayes theorem is a method by which we can calculate the probability of an event given that some conditions has already been satisfied and that conditions belong to this particular event A. So what this means is what is the probability of event A or the occurrence of event A given B has already occurred. So this can be given as probability of B given A has already occurred multiplied by probability of A and divided by probability of B. So what is this probability of B here is probability of B can be given as summation I equals to 1 to n, and this is probability of B given AI into probability of AI. So here also you can write the term AI. Please watch my Bayes theorem video to get more clear on this particular point. Now this is the Bayes theorem, but how this theorem is used in our particular case, that is naive Bayes, is like this. In machine learning, what is our problem? Our problem is we have to approximate a function that can that can map that can map a given data point to its particular label. So what is y? Y is the label of that particular data point x that will be given to us. Now this is the same formula here that we are using here. What we have to do is we have to give the probability, or we have to find whether this particular point belongs to class 1 given that particular point is already given. So we have been given x, we have to find whether this particular point belongs to class 1 or not. So the same thing will happen for class 0 also, and we all know that class 1 is treated as positive class and class 0 is treated as negative class. And in our videos, or in all those videos that I am making, we will be only considering class 1 because both these are symmetrical, you can solve for anything. So given this particular x, we have to find what is the y of this particular x. So this is same here. So using this particular formula, what we can do is we can write probability of y equals to 1 given this x can be written as what is the probability of x given y equals to 1 multiplied by probability of y equals to 1, and what is the probability of x. So what is this probability of x is, this can be given as probability of x given y equals to 1 multiplied by probability of y equals to 1 plus probability of x given y equals to 0 into probability of y equals to 0. Simple. Now you must be wondering what are we actually doing in naive Bayes. So in naive Bayes we are trying to estimate this particular thing. Why? Because this is already known. See, in our whole of the training set, what we have is we have various points, and that points will either belong to class 1 or will either belong to class 0. So if someone says you what is the probability that y equals to 1, so what we can simply do is all points that belongs to or that have y equals to 1 divided by all points. This will give us the probability that y is equals to 1. Simple. And what is for y equals to 0? Same thing, but the here y should be 0 for all points, and here all points, the number of the total points that we have in our training set. Simple. So this is y equals to 1 and y equals to 0. But this is not given. This is what we will be learning. How to learn this? So this is all about the naive Bayes algorithm. So I will show you how we will learn this x, probability of x given y equals to 1, and same thing can be for given for y equals to 0 also. So I will only focus on this for now. Now what is this? Let me explain it to you. What is probability of x given y equals to 1? So now we all know that this x is not a variable. This is a vector. So what is this vector containing is this x contains x1, x2. It will go until xn. Now what is this x? X is the vector representation of a given data point. For example, suppose we are doing sentiment analysis, or we are saying whether a given sentence is positive or negative. By positive I mean the sentiment is positive, and by negative I mean the sentiment is negative. So these x1, x2 and xn will be the features of the data point. So you all know that we can vectorize the data by using featureization. So I will not be explaining featureization here. I have some videos in my machine learning series. There you can go and watch that. Now suppose now we have x1, x2, and these all are variables. They can take any value. And now the problem becomes like this: x1, x2, x3 until xn given y equals to 1. Now these all are given. Now the problem is like this. We all know that in probability we have chain rule. What is that chain rule is? Suppose we have something like this: a1, a2, a3, a4. So if we want to know the probability of this thing, so we have to write the formula as probability of a1 given a2 till a4, that is a3 here, multiplied by probability of a2 given a3 a4. This is a2, this is a3, this is a4, multiplied by probability of what is this is a3 given a4 and multiplied by probability of a4. So same thing that is here, same thing here. And by this probability of a1, a2, a3, a4 means probability that a1 intersection a2 intersection a3 intersection a4. So this is same here, because x1, x2, x3 should all occur and y should also occur. Then we have to find this particular thing. What is the probability of this given this? So this can be written as like this: probability of x1 given x2 until xn, and at last we have y equals to 1, that is y equals to 1, multiplied by probability of x2, and we have to go from x3 till xn, and then we have y equals to 1 also, given y equals to 1, and so on we will go probability of this is xn at last and given y equals to 1. So this is our whole thing. Now this term itself will take a lot of time to calculate. This term itself will take a lot of time to calculate. So this is not feasible. This is not feasible because we will have multiple terms. So what is the assumption that we make in naive Bayes is this: the value that x1 will take is independent from the occurrence of x2 or not. But see what I am trying to make is, suppose this is x1 given x2 until xn and given y equals to 1 also. See what I am trying to make is the probability that x1 will take some value is independent of what value x2 will take, what value x3 will take, and until xn given y equals to 1. So this is conditional independence. By conditional independence I mean that given the class is 1, the probability that x1 will take some value is independent of other variables that we have. Once this is assumed, we can simply write this whole term as probability of x1 given y equals to 1. And same for all the variables. Now since we had that long term, the long term that we had was probability of x1 given x2 till xn given y equals to 1 multiplied by probability of x2 given x3 till xn and given y equals to 1, and so on. At last we had probability of xn given y equals to 1. So when we assume that this variable is conditionally independent from other variables, or all the variables are conditionally independent from other variables given the class y equals to 1, then this whole term boils down to this particular thing. So now we can simply write as probability of x1 given y equals to 1 multiplied by probability of x2 given y equals to 1, and we can go until probability of xn multiplied by probability of xn given y equals to 1, and at last probability of y equals to 1 simply, and we know that this is our whole formula. So now we have this whole term. Now we can simplify this as like this. We can say this is pi and this is I equals to 1 and it will go till n, And what is this? Probability of xi given y equals to 1, and this term is constant, and we know that we can simply get this from our training data, and this is probability of y equals to 1. So this is our whole formula. And what is this? This is probability of x given y equals to 1. So this is what we have to learn from our training data. Now I will explain what is xi and how to calculate this xi, and that will be very interesting, and then you can understand how we are doing this. And one more thing, see, we had this term probability of x given y equals to 1 into probability of y equals to 1, and in the denominator we had probability of x. And why we are not using this term? Because this term will not make any difference in classification, because this will be always constant, and this will be 1. So this will not be 1, sorry for that. This will be constant, and I will show you why this will be constant. We only have to find this particular term, because this we will already get from this our training set. So I will end this video here, and in the next video I will explain what is xi, how to calculate xi when this is y equals to 1 and when y equals to 0, and why we are ignoring this particular term and only calculating this particular term. So I hope you like my video, and the explanation that I am giving is satisfying you and is giving you some clarity on how net base works. And if you really like my video, then please do consider subscribing to my channel. And as always, thanks for watching my video, and I will see you in my next video.